Hello everyone, this is Ashwini from Cheenta.com. Today we will be learning 3 concepts from Math Olympiad Geometry. And we will learn them using a problem from American Math Competition 10. This video is created at Cheenta.com. Particularly, this one is related to the 2 courses, the live course on AMC 10 and IOQM and the self-paced course on AMC 10 and IOQM. If you are interested in these courses, you can check the link in the description. Let's get started. So what does this problem say? It says that there are 2 circles, C1, this is the first circle, and C2, this is the second circle. Both of them intersect each other at 2 points. There is a third circle, C3, that is tangent to both of them, both of C1 and C2. So C3 is tangent to both C1 and C2, internally tangent. And C4 right here is tangent to C1 and C2 internally and tangent to C3 externally. We want to find out the radius of C4. That's our goal. So you can pause here and try the problem on your own. C1 and C2 are the bigger circles and they have radius 1. And the distance of their centers is half. Centers are half units away. Okay? C3 is tangent to C1 and C2. Just like this. And C4 is tangent to all 3 of the bigger circles. And we want to find out the radius of C4. So while we solve this problem, as usual, we will be learning some concepts. And that is how all the Cheenta courses and all the videos are created. They are created around some problem from which you can learn something. Okay? So here are the 3 things that you will be learning from this particular problem. The first one is about the relationship between tangent and radius. Tangent to a circle is always perpendicular to the radius. So we'll talk briefly about that. Then we will talk about something called collinear points. 3 points are collinear. They lie on the same straight line when certain special things happen. And we will talk about one such condition. And finally, we will also take a deep dive into an axiom from Euclidean geometry. Euclid's geometry is built on certain axioms or given facts, and all the theorems can be deduced from them. We will talk about one such axiom. Okay? So the first thing is tangent is perpendicular to the radius. This is like this, that if you have a circle and if you have a tangent line, a line just touching the circle, and if it's the center, O, this is the point of tangency, suppose T, and this tangent is XY, then OT is perpendicular to XY. Why is that? I'll give you a hint. If you join any other point, let's say R, notice that OT is equal to the radius, and that is smaller than OR. That is, OT is the shortest distance from O to the tangent line. Because all other distances from O to the tangent line will be greater than the radius, therefore it's greater than OT. Right? Okay. So OT is the shortest path from the point O to the tangent line, And shortest path from a point to a line is a perpendicular line. Shortest path from point to line is perpendicular to the line, is a path that is perpendicular to the line. Can you prove that? Can you prove that the shortest path from a point to a line is the perpendicular line from that point to that particular line? If you can write it down in the comment section. I think you have to think a little bit about this. Alright? Alright, the second thing is the concept 2. This is 3 points on a line. 3 collinear points. So it's a very typical scenario. If you have a circle, if you have another circle that is tangent to it. Okay? So maybe I can draw it in a different way. Let's draw it internally. Tangent to it. Work with this point of tangency T and the two centers, so O1 and O2. O1 is the center of the bigger circle. O2 is the center of the smaller circle. T is the point of tangency. Something very nice happens. O1, O2, T are on the same straight line. This is a straight line. Why is that? Why? Because O2T is perpendicular to the tangent line here. Let's call it XY. And O1T is also perpendicular to the tangent line at the same point T. If O1T is perpendicular to the tangent line and O2T is perpendicular to the tangent line, and both are perpendicular at the same point T, then they have to be the same line. Why is that? This is because of the third concept, which is concept 3, which is Euclid's axiom. So this axiom says that if you have a line and if you have a point on the line, let's call it P, then there is only one line that is perpendicular to XY passing through P. Or let's call it T because that's what we have called it earlier. Given a line, given a point T on the line, there is a unique perpendicular passing through T and perpendicular to XY. There exists a unique perpendicular line. That is why O2T and O1T must be the same straight line. O2T is perpendicular to XY. O1T is also perpendicular to XY at the same point T. Therefore, O1T and O2T must be lying on the same straight line. Therefore, O1, O2 and T must be the same straight line. Okay? Alright, that's great. So, I hope this is understandable. Now, let's go ahead and talk about the problem. We have these two circles with these two centers, C1 and C2. So if I extend this, this will hit the point of tangency. And if I extend this, that will also hit the point of tangency. So this much is 1, this much is 1. So what is this much? Well, it's 1 plus 1 minus half, that is 3 by 2. This is the diameter of the smaller circle C3. This much is 1, this much is 1, half is common. So I'm over counting half. I'm counting it 1 times extra. So 1 plus 1 minus half, that is 3 by 2. Okay? So what is the radius of this C3 circle. The radius of the C3 circle is half of the diameter, which is 3 by 4. So this is 3 by 4. And I could extend it to the center of this little circle. And they will be on the same straight line. These two centers and the point of tangent C, all of them will be on the same straight line. This is something that we just discussed. All of these 3 points will be on the same straight line. Therefore, it's a straight line. This little portion, let's call this X. So from the center of C4 to the center of C3, we have X plus 3 by 4. Okay? Now, let's look at this one carefully. We have C1 and C4. These are tangent to each other. So from the point of tangent C to the point of center, so this center point, and this point of tangent C, they have to be on the same straight line. This portion is X, this little portion. This little portion is X. Here we go, because that's the radius. That is X. And if I just extend it, this total thing is 1, because that is what the radius of C1 is. So up to the center, it's 1 minus X. This much is 1 minus X. And this little portion is 1/4. Okay, so we are done actually, because this much is 3 by 4 plus X. This much is 1 minus X. And this little portion is 1/4. So we have a right angle triangle. You can find out the value of X. Can you find it out and send it to me in the comment section? I think you can easily do it by using Pythagoras theorem. I hope this problem was useful for you. We learned quite a bit. We talked about collinear points. We talked about Euclidean axioms. And we talked about tangent is perpendicular to the radius, and how all of these 3 concepts come together to make one problem. I hope you liked it. Please check out the programs on mathematical sciences, Mathematical Olympiads in the link in the description. We have live classes as well as self-paced programs. I hope you like it. Thank you, and I'll see you in the next video. Bye.